have two equations with two unknowns, we really have a system of equations. And the great challenge is to see if we can find all the unknowns. And it turns out, since we have a lot of equations, in this case like 2 and 2 unknowns, we can actually figure out what both unknowns are, usually x and y. So let's take a look at an example where we're, for ourselves, going to figure out both x and y. So I want to solve this system. And that little bracket there, that little brace, that curly bracket, just indicates that it's one system taken together. So we want to solve x minus 2y equals 6, and at the same time, we know that the same x and the same y satisfy 3x minus 2y equals 8. Okay, so how do we proceed? Well, of course, we can use all the techniques of algebra that we have, but we can also take a look at what this looks like visually. And we can actually use all the techniques of graphing to see an estimate for what the answer is and to see if the answer we end up getting is reasonable. So, to start off by graphing, of course, the first thing I love to do is to look at the coordinate plane. So there's the coordinate plane. And now I want to just plot a couple points. There's lots of ways of graphing. We know how to graph these type of things. So here's one way. One way is just to make a table. So here, someone gave us the x values, which is always so handy. So 2 and 6. And now we have to find the corresponding y values. So what we have to do is we have to let x equals 2 here and solve this. So if I let x equals 2, then it's going to be 2 minus 2y equals 6. I'll just write that down for fun, but I'm going to erase this really fast. So this will just be 2 minus 2y equals 6. So if I subtract 2 from both sides, I see negative 2y equals 4. Divide both sides by negative 2. And we see that y equals negative 2. So I see this value, in fact, is negative 2. If I let x equal 6, that's actually really easy to do. We can almost do that in our heads. Because if x equals 6, I have 6 on this side and 6 on that side. If I subtract 6 from both sides, then the 6 is simplified to 0, and I'm left with negative 2y equals 0. Negative 2y equals 0, then y equals 0. So that actually means that the corresponding y value is 0. So, okay, so now let me just get rid of this little scratch work here. We don't need that anymore. So now, given these 2 points, since we know 2 points determine a straight line, we can actually plot these things. So let's actually plot them for ourselves. So let's see. We have 2, negative 2. So that's 2 in the x direction, negative 2 in the y. I'm going to put a big circle-y kind of thing here. And then we've got 6, 0. So that's going to be 6 and then 0. So that's going to be right here. So that's what we have for those two. And if we connect them with a straight line, we'd see the line. And of course, the magic of me is that I actually have my lines prepared. Please. Professor Berger doesn't actually make his own lines anymore. He's way too important. Way too important. My lines, I custom make the lines. Okay, so there's that. Now we do the exact same thing with the other line. So we make a little table, and again, luckily someone gave us some handy points. If you plug in 4, it turns out in this case, if you let x equal 4 and solve for y, you're going to get 2. You can try that and then see if I'm actually right. And if x equals 0, we can do this actually in our head. If x equals 0, all that is just 0. So I have negative 2y equals 8, and so therefore y must equal 8 divided by negative 2, which is negative 4. So we can see for ourselves it's negative 4. And now we can actually plot these points. So for the second line, we see 4, comma, 2. So that's 4 and then up 2. So that's this point right in there. And then here we see 0, comma, negative 4. So that's going to be 0, and then we go way down, negative 4. Now you can connect those with a straight line. But of course, Professor Berger has a bouncy line already prepared. Boom, there we go. So, we are looking to solve this system. Visually, that's asking, where do these two lines intersect? Well, just visually, you can look at it and see they seem to be intersecting right here. And if you notice, that seems to be when x equals 1 and y equals something between negative 2 and negative 3. So that seems to be our guess. But we're not even sure about the 1. It might be a little bit more than 1, a little bit less than 1, and who knows exactly. Well, if you want to find the exact value of that point right there, what you have to do is, of course, solve it algebraically. So let's now take a moment to actually look at how we'd solve this algebraically. So let's let all this go away. Bling. Okay, and now let's just do some fun algebra. So the way to solve two equations and two unknowns, one way is to see if we can isolate one unknown in one equation and then substitute it into the other. Let me show you what I mean. If I take this equation right here, this one equation, and solve it for x, I would just add 2y to both sides, and I'd see this is the same thing as saying x equals 6 plus 2y. It's the exact same, it's equivalent identity. It's equivalent equality. The only thing is I added the 2y to both sides, so it's written this way. Well, if x equals that, and that's the same x that appears here, because remember I told you those values are the same, then I could in fact take this value for x, it's just a different name for x, and I can now insert it right in for this value for x. And notice then I'll have just one equation just in terms of one unknown, in this case y. And that's how we solve these things. So if we put these things together, what we would see is the second equation will become 3 times, now instead of x, I'm going to write all of that stuff. I'm going to make a mistake right now. See if you can catch the mistake, but I'm warning you, there's a mistake. So this is 3 times, and then all that stuff. So 6 plus 2y. And then don't forget about this stuff, so that's going to be minus 2y equals 8. Now, I just said there was a mistake here, and yet it looks so good, right? Because instead of the x, I put in the 6 plus 2y. Right? I'm multiplying it by 3. I then subtract the 2y, and that equals 8. What's the problem? The problem is what I wrote is not what I said. Because I'm supposed to have 3 multiplying all of x, and x equals all of that stuff in the lasso. You see something in a lasso, you better lasso it algebraically, which means putting parentheses around it. Because now I know I have to use the distributive law, the distributive property, to take the 3 and multiply it by the 6, but also multiply it by the 2y. Without those, it's only 3 times 6, and then the 2y is hanging out by itself. So we have to lasso the whole thing in, which is what we did here. Lasso, lasso. Whenever you're lassoing, parentheses. Now we know exactly what to do because we have to distribute. And so if we're going to distribute, we see that we have to multiply the 3 by the 6, but also the 3 by the 2y. And so now what we see, this is equivalent to 3 times 6 is 18, plus 3 times 2y is 6y. And then don't forget we have the minus 2y equals 8. Now here's a great mistake someone might make. They might get so enthusiastic they'll multiply this 3 by the negative 2y. But that doesn't make sense because the lasso is only around here. We only multiply where the parentheses are. So that 2y just remains as is. Now we simplify and combine like terms. So we have 18, and if I have 6y's and someone takes away 2y's, I'm left with 4y's. It's like when people call me sometimes, 4 eyes. I know, it's 4 Y's. Everyone calm down. All right, so now what do I do here? The thing I'm going to do here now is I'm going to undo the addition of 18 to isolate the Y. So I'm going to subtract 8. Well, that's an awful subtraction sign, isn't it? That's weird, isn't it? Why did that happen? There, that's much more healthy. Do it on both sides, though, of course. And when I do that, what do I see? Well, I see this simplifies to 0, so I'm just left with the 4y. And then here I see 8 minus 18, which is negative 10. And then if I divide both sides by 4, I see that y equals negative 10 fourths, which simplifies to just negative 5 halves. So that gives me what y equals. Well, that's great, except for the fact that I need to figure out x as well, because I have 2 unknowns. But I can go back and actually figure out what x is by inserting the value we now know y equals. So we can now come back up to here and say, okay, well, now we know this is 6 plus 2 times, well, y we just discovered is negative 5 halves. So we can simplify this. This is 6 plus, well, if you simplify, see there's a 2, the top 2 on the bottom, we simplify, this becomes negative 5, and so 6 plus negative 5 equals 6 minus 5, which is 1, and so that equals x. And so I see what x equals, I see what y equals, And so I see that the solution, which I can write as x comma y, is 1 comma negative 5 halves. And so that's the solution that we found to this system. So that is what we've got. That's the solution to this. Now, does that make sense? Well, let's go back to what we did earlier. So let's go back way back to this thing. And let's now see, here's our solution. And let's see if that makes sense. Well, let's graph it. If we actually put a point here, we're looking at 1, and negative 5 halves is negative 2.5, and check it out. That's exactly where that point seems to be. Right there. And we can see it for ourselves. So in fact, this point really is exactly at the point of intersection. And so we see that our estimate is actually reasonable. And in fact, this picture is much more accurate than we would have even guessed because we found the exact answer. The exact answer in this case is that x equals 1 and y equals negative 5 halves. And if you plug those into either of these equations, we'll see an equality. So, if you have a system of equations, there's lots of ways of considering it. We could, first of all, just try to graph those different equations on the coordinate plane and see where the point of intersection is, if there is one. If there is one, then we have a solution. And then we could actually use algebra to find the exact, precise, exact value. And of course, in math, it's all about being exact. Have fun looking at systems of equations in your life. I'll see you soon.